Assalamu alaikum guys, welcome back. Finally we are here with the first video of advanced levels, GCE A levels. Here we go. So first of all we are starting from the P1 of the enthalpy change chapter from chemistry. Disclaimer: one thing is being told here that A levels is much harder than O levels. In O levels there are very small calculations, especially in the case of chemistry and also in the physics. A levels, it is complete opposite. It is advanced level, and it is highly advanced level for an O level student. And just for just for making a bit of understanding to A levels, I had said that taking A levels and taking the sciences subjects and then absorbing them is a complete set of tasks that is needed to be performed over a long period of time. So some of you guys might be boggled down, and you would say that how are we going to do A levels, it is very difficult. So there's just one thing: you have the motivation, you got the patience, you got the courage, you got the resilience, and you are honest in evaluation, then obviously you would ace it. Anyways, we are going to start from chapter 5, enthalpy change. We are doing P1 today only, and this is the first video of my YouTube channel, Captain AB P1 chemistry A levels. Now here we go then. Before starting, one thing is being told that I will only tell the technique. You have to do calculations on your own. I have already solved the paper, so I will just be getting over the techniques and the concepts which are being thoroughly applied throughout this topical P1. You will have to do the calculations. Okay, now we start with question number 1. Ethanol is increasingly being used as a fuel for cars. Okay, the standard enthalpy change of formation of carbon dioxide is this. The standard enthalpy change of formation of water is this. The of ethanol is this. What is the standard enthalpy change of combustion of ethanol? Now when you have been given like formation, the heats of formation, you have to calculate the change in combustion. You will apply what? Hess's law. And according to Hess's law, the calculations, the arrangement when you are doing the calculation is something like that. You arrange the elements which are obviously C, H and O. It is a hydrocarbon ethanol, C, H and O, in this side on the upper left, and then you draw an arrow to make the compound which is being formed, C2H6. It is all obviously ethanol. And now why have I added three oxygens? Because now I am to draw a combustion diagram. So this and this obviously would give the same products after combustion, and that would be CO2, and obviously that would be water. Be cautious of one thing: be sure to balance the equation. So you add 2 here and you add 3 here, because you have to balance the C2H6. Now rest of all is simple calculation and simple maths, and I draw one arrow in this way. Now what is the direct route? This is the direct route. I call this D. This is dx1, the indirect route, and this is dx2. So D is equal to dx1 plus dx2. I have to calculate what? I have to calculate this dx2. So D minus dx1 is dx2. Now what is just a second, what is dx1? Dx1 is the enthalpy change of formation of ethanol, because ethanol is being formed here. So dx, and it is what? Minus 277. So D plus 277, because minus times minus is plus. So dx2. And for D you have to take 2 formations of carbon dioxide and 3 formations of water. You add them both, so this would be obviously a negative number, and then from the negative number you add 277. So your answer would be B. You will do the calculations as I said, because everything is about a technique. Rest of the calculation is simple mathematics. Even an sixth grader or eighth grader will do this. Okay, now We move on to question number 2. In an experiment to calculate the combustion of a fuel, okay, 1.5 gram. Just a second, let me change the color. I guess a maroon would be much better. Okay. In an experiment to calculate the enthalpy change of combustion of a fuel, 1.5 gram. Oh, so it's already given us the moles. Nice. Of the fuel was used to heat 200 grams of water. The temperature of the water rose from 25 degrees C to 55 degrees C. The specific heat of capacity of water is 4.18 joule per gram Kelvin. There is a significant heat loss. Therefore, the experimental value for the combustion will be different from the theoretical value. Okay, so using the information, what is the enthalpy change of combustion's value? So simply you have to apply Q is equal to MC delta T. We have been given mass which is 200 grams, and we have been given what? Just a second. We have C. Obviously, we know C is the specific heat capacity of water, 4.18, and the change in temperature. Now the temperature is changing from 25 to 55, so it is obviously 30 degrees C. So this would be 200 times 4.18 times 30. So this would be 25080. But be cautious of one thing. What? It is was 0.0326 moles. Means that 0.0326 moles is giving what? 25080. We have to calculate the enthalpy change of combustion for 1 mole. It is based on the definition of enthalpy change of combustion that we have been given to take the enthalpy change of 1 mole. So 1 mole would give how much? You simply multiply these, and this would be 25080 divided by 0.0326. 25080 divided by 0.0326. So this is 7,69,325. So this would be, what was there? 0.0325. This is 7,69,000, and you divide this by 1000. So this would give your value as minus 769 kilojoule per mole. Why? Because in combustion there is always a heat evolved. Always there is a heat loss, there is heat evolved combustion. Okay, now part 3. For which equation is the enthalpy change correctly described as enthalpy change of formation? What is enthalpy change of formation's exact definition? It is defined as the enthalpy change when 1 mole of a product, so you ignore D first of all, is formed from its reactants in standard conditions at room temperature. So yeah, that's the yes, that is the definition. So under standard conditions in their normal physical states, carbon in its normal physical states is solid to form what? 1 mole of a compound. And now you might be arguing that among B and C which is correct. Now these are atoms, these are already atomized. It is called enthalpy change of atomization. This will be coming later on in the MCQs. So these in C, nitrogen and oxygen have been atomized, whereas in B they haven't been atomized. They exist in their normal physical states. Oxygen is existing in its gaseous states, whereas carbon is existing as graphite. We generally call the solid graphite. So obviously B is the right answer. Again, I am recalling the exact definition. It is defined as the change in energy when 1 mole of product is formed from its reactants under standard conditions in their normal physical state. So always, now first thing before solving the P1 of enthalpy, go ahead and revise all the definitions that you have learned. Otherwise you will definitely get much issues in much issues, and much higher issues than other P1s of like moles and moles, stoichiometry, redox, you will get much more issues and much highly magnituded issues in this P1. Anyways, uh, okay, now we move on to part 4. अगर मेरा कोई दोस्त देख रहा है तो वो उसको समझ लग गई होगी कि मेरी उर्दू में थोड़ा सा खराबी है, तो उसके लिए माजर चाहता हूँ. और एनीवेज, क्वेश्चन नंबर 4. The standard enthalpy changes of combustion of glucose and ethanol are given as -2820 and -1368 kilojoule per mole respectively. What is the standard enthalpy change for this reaction? Again, you have to apply the Hess's law. We know that both glucose and ethanol upon combustion would yield carbon dioxide and water. So first of all, you draw this plot type, you draw this diagram C6H12O6 blah blah, and this would give us C2H5OH. You must add 2 here because this is the standard. This is standard, क्या बोलते हैं, what is this called? This is the balanced chemical equation. Oh yeah. Okay, and this would give me CO2 along with water. Acha, now what we are to find is the enthalpy change for this reaction. We have to calculate the enthalpy change for this forward reaction, and what we have been given is the enthalpy change of combustion of ethanol along with the enthalpy change of combustion of what? Glucose. Yeah, obviously. So this would be of enthalpy change of glucose, and I call this would be of ethanol. Now draw direct and indirect routes. So this would be the direct route because you draw a vector diagram. So this is the direct route. So delta Hg, always draw vectors. I'm not explaining vectors here. Draw vectors, then solve this, because this would most likely, after doing this, you would be able to comprehend the directions in which you are to go. So change in combustion of glucose is equal to HR, which we are to find, and change in combustion of ethanol. So change in combustion of glucose minus 2 change in combustion of ethanol. Now you might be wondering why I have added 2 here, because in the normal chemical, just a second, in the normal equation he has given 2 here. Let's change the color of this highlighter. Yeah, this would work. Okay, and I have added 2 here because we are being we are combusting 2 moles of uh, ethanol according to the balanced chemical equation. Now you do the calculations, you put ethanol glucose's value and the ethanol's value, and this would be equal to B, minus 84 kilojoules per mole. Again, I am relying the calculations on you guys. Okay, now so this P1 has been randomly arranged. So I'm going now, we are moving on to question number 9, I guess. Okay, so this is a bit trickier question. Question number 9. The equation for complete combustion of propanol. Okay, so this is again an alcohol is shown. Standard enthalpy changes of formation are given. So we have been given the enthalpy changes of formation of delta H of ethanol itself, the carbon dioxide, and the H2O. Okay, now what is the standard enthalpy change of combustion of propanol? Now we are combusting this whole thing. Again, as the question number 1 in the start of the video, you apply Hess's law in the same directions. You write the elements here, you make the product which is propanol. I'm not writing the whole statement, propanol, and then you also have the water here. And now I'm also not writing water because it is not needed here. I'm not writing any other thing if it is being made, so do not worry for this. And we now know that both, like, the elements would produce the same carbon dioxide and water, and the propanol would produce the same carbon dioxide and water. So you would draw a diagram here. So this would give us CO2 along with 4H2O, and I add 3 here. Again, you might be wondering why I have added 3 and 4 here, because this is the normal balanced equation. According to the balanced chemical equation, when 1 mole of propanol is burnt, 3 moles of CO2 and 4 moles of H2O are produced. Anyways, now simply the rest is simple maths. What we are to find is enthalpy change of combustion of propanol. So we have to find, let me just give this the names. I call this delta X, delta Y, and delta Z. So the direct route is delta Z. Again, I'm not explaining vectors. You should be knowing what is vectors. Why are you doing P1 topical even if you do not know how to go for the directions in this diagram? Delta Z must be equal to delta X plus delta Y. We have to find delta Y. So delta Z minus delta X is equal to delta Y, and delta Y is the standard enthalpy change of combustion of propanol. Okay, now what I'm gonna do is, what is delta X here? What is delta X? It is the enthalpy change of formation of propanol. So this would become delta Z plus 303. Why I have added 303 instead of minus 303? Because there's a minus sign here already. So this is delta Y. So the space is a bit short. So 303 plus, now I've got enthalpy change is a formation of CO2 and water as well, plus Z is minus 4, because there are, so no, not there is I add 4 into 286, and this whole is multiplied by minus 1 plus 3 into 394, sorry, 3 into 394, and this is multiplied by minus 1 because there is a minus sign actually here. And you do again the rest of the maths, so obviously B appears to be your right answer. He has just tricked you here just to check your concepts of mathematics, pure maths here. He will take minus 1 common, minus 2 common, and then you would do the, okay, so minus 1 times minus 1 is plus 1, and some of you would go wrong, so this would actually cost you a 1 mark. Anyways, question number 10. A student makes 25 cm cube of 4 mole per decimeter cube HCl with an equal volume of blah blah blah. Okay, 4 mole of decimeter cube sodium hydroxide. The initial temperature of was 15 degrees C. Final was 30 degrees C. Using these results, what is the enthalpy changes of neutralization of hydrochloric acid? Again, this is a tricky question. Only very small trick is involved. Very small concept. Be cautious of the number of moles here. I will calculate moles here. Is what is moles? Is molarity, or you can see the concentration times the volume. We have been given the molarity 4 and the volume is 25. So 25 is 0.025 decimeter cube. Always convert it to decimeter cube, and then I multiply this by 4. So this would give us 0.1. What I want to say is, after doing the calculations of this whole part, we would only get the enthalpy change, or we would only get the energy released for 0.1 mole of the 0.1 mole of HCl. Okay, and we are to find the enthalpy change of neutralization, and enthalpy change of neutralization is always for 1 mole. It's always for 1 mole. Why am I saying 1 mole? Because it is in the balanced chemical equation. Now why I am writing the balanced chemical equation, NaCl, NaOH plus HCl, this would give us NaCl plus H2O. But the definition, when 1 mole of water is formed, so in this reaction there is 1 mole of HCl, so we are to calculate the 1 mole enthalpy change of neutralization of HCl. So I will do the calculation for the whole paragraph. Just a second. Okay. Q is equal to mc delta T. So this is what 3150 joules. I apply what mass? Mass is 25 plus equal volume. So 25 plus 25, 50 is the mass. C is 4.18. Temperature difference is 15. So you would get 3150 joules for what? 0.1 mole. 0.1 mole I am to calculate for 1 mole. So you simply do the cross maths and you would get your answer as 315. Just a second. 3150 31400. So so this would give us 31400, something like this. And this would be, and you convert, divide this by 1000, so you would get 31.4 kilojoule per mole. Again, the issue is why there is a negative sign here. The neutralization reactions are always negative. In the course of A levels, there are exceptions actually, but these are not being told. In your titration P3, almost I mean, all of the reactions you do, the temperature of the reaction mixture falls. Sorry, the temperature of the reaction mixture increases over the time, especially for the KMnO4. There's a drastic change when you touch the beaker. Not for always, not for all the students, but for some there is a drastic change. Like they can feel the heat when they are doing titration or something like this. I'm not again exactly what they are doing, but generally in neutralization there is energy released, so you add negative sign here. Okay, now so question number 11. So this is a tricky one definitely. All the reactants and products of an exothermic reaction are gaseous. Okay, exothermic reaction, which statement about this reaction is correct? So delta H for the reaction is negative. Yes, it should be. It would never be positive. It would never be positive. So you are already left with either A or either C. Now again, here is a tricky part. So this would actually tell you what is the difference between O levels, IGCSE, metric, inter, and A levels. The total bond energy of the products is less than the total bond energy of the reactant. So you try to draw an energy profile diagram for an exothermic reaction. It is like this. So the energy of products is always lesser. Now you are true, and you would obviously go for the total bond energy of the products is less than A. So you would go for A actually. But be careful again. He is saying total bond energy. Why would be the heat evolved? Why would be the heat evolved when the total bond energy of the products is more than the reactants? So that's only when the reactant, that's only in this case when the heat would be evolved. So C is the right answer, because he is saying the total bond energy of the products. So bond energy of the products must be higher, and that's why there is a release of energy. Okay, now for part 12, again this is for a Hess's law question. CH4 plus, okay, now which expression gives the standard enthalpy change of combustion of methane? So this is the methane's combustion. So I write C plus H2 as I had told in MCQ 1. This would give me CH4. Now both of these would yield CO2 and water upon combustion. Okay, so this is delta H. I call this. So this is actually the formation of CH4. Okay, and this is combustion of carbon. Delta H combustion of carbon plus delta H formation of H2O. So there was an issue here. It was the formation of CO2 here. Sorry, CO2, because one CO2 is being produced and one H2O is being produced, and this is the delta H2 which we are to find. So according to this, the equation balance means delta HF of CO2, formation of CO2 plus 2 delta HF, because there are 2 moles of water being formed under the standard conditions. 2 delta HF H2O, mind my writing, is equal to delta HF of CH4, formation of CH4, along with delta H combustion of CH4. So you take this to this side and you subtract it, so you would get D as your right answer. Now we move on to question number 5. This is actually very easy question. The diagram shows a reaction pathway for an endothermic reaction. Which arrow represents the activation energy for the forward reaction? This definitely B. Part 6, I won't be telling you why this B. You have already done this in the O levels. Part 6, metaldehyde is used as a solid fuel for camping stoves. Okay, so you go for a hiking in Gilgit Baltistan and associated areas, and you go for the camping, so you might be using metaldehyde. So yeah, that's good increase in general knowledge by Cambridge. The equation for complete combustion of metaldehyde is shown. Okay, I see it. For complete combustion, okay, which expression will give a correct value for enthalpy change of formation of metaldehyde? So you have, so just a second, again for using the Hess's law, as always, carbon plus hydrogen plus oxygen to give me metaldehyde. I'm calling this no, I'm writing this metaldehyde. Okay, this would be the enthalpy change of reaction, and what we are to find is enthalpy change of formation of metaldehyde. So we are to find this one, this arrow, this vector. I call this delta H of, no, he's asked for formation of metaldehyde, so this we have to find delta HF. Just a second, delta HF, this is to be find. Okay, so just a second. Okay, metaldehyde, and this is the combustion of metaldehyde, delta HC of metaldehyde, and this is the other combustion side. Obviously they would produce the same things, carbon dioxide and water, 8CO2 plus 8H2O. Why I have added 8 and 8 here? Because this is the balanced chemical equations. You may also write 10O2 here just for your sake of understanding. In P2 you have to write it. Now in P1 it is not actually required. You only have to select the right answer. Okay. So I add 8 here according to the balanced chemical equation, and 8 here again ignoring oxygens. So what I have to find is delta HF. So according to this, delta HC this side is equal to delta HF by vector addition plus delta HC of this side. What I am to find is delta HF. So delta HC actually. So delta HC here is 8 combustion of hydrogen plus 8 combustion of hydrogen molecules. So okay, now again I'm revising one concept here. When you go for the combustion diagram, you always write elements in their normal physical states here. So I must be writing O2 here as well. I won't, if I would write 16, means that the hydrogen molecules have been atomized. So this is what we do not obviously want here. We want them to be molecules. So you write molecules here. So, and that's why it is 8H2, not 16H here. So what I have been given here is delta HC. So 8 HC carbon plus 8 HC of hydrogen gas, and I minus combustion of metaldehyde. Call this M. So C is your right answer. I'm not writing the whole statement because the video will get too longer. if I go for it. So question number 7, nitric acid and bromine vapor react together according to the following equation. So the reaction has an activation energy of 5.4 kilojoule per mole. The reaction is exothermic. So this would be D as your right answer. The activation energy is always drawn with its arrow upwards, and the enthalpy change is drawn in its original direction. So C is the right answer. All other are incorrect. So okay, now part 8. So this is the activation energy. Obviously, it's not. Again, this is not activation energy. Here, the arrow's direction is the issue. Question number 8. Gaseous phosphorus pentachloride can be decomposed into phosphorus trichloride plus chlorine by heating the table gives the bond energies. So what is the enthalpy change for decomposition of PCl5 to PCl5 to PCl3 and PCl2? So PCl5, now I will go for drawing the bonds. So there are 5 PCl5 here, and this would give me 3 PCl and 1 Cl to Cl bond here, and you draw for atomized atoms 5 Cl here, and you go in this direction, and likewise. So I call this because the 5 PCl5, obviously it is being atomized, so this is change of atomization. So change of atomization is equal to delta H of reaction, delta HR of the heat of reaction, which is, or the decomposition which we obviously want here, delta H of decomposition, so delta HR, this would work okay, and along with delta H plus delta H of, what will I call this, decomposition. It is again the PCl5, PCl3 and Cl2 are, I will go for decomposition here actually. So for decomposition of this part, not for this. Okay, so 3 PCl, 339, so this is 990 and this is 242. So this part for this arrow, it is delta HD, which I have been given here, is 1232. 1232. There are 5 PCl and 5 PCl bonds being broken here, so it is 1639, not 1630, 1656 on this side, because PCl is 330 times 330 times 5, 1650, and this is delta HR, which we are to find. So 1650 minus 1232, 418. D is your right answer. Okay, so now we move on to question number 38. The equation for reaction 1 is shown. Okay, so I am seeing it actually. What is the correct expression for the enthalpy change of reaction 1? Enthalpy change for reaction 1 is shown. Okay, so this is the reaction 1. This is the correct change for enthalpy change of reaction 1. These are the enthalpy changes of combustion. Or down, now I can solve this. This is again using Hess's law, C6H12O6, and to form C2H5OH. You draw a vector triangle or vector diagram. Enthalpy change of reaction 1, this is the delta Hx, which is delta HR, which we are to find. I call this delta H1, delta H2. So H1 is equal to H2 plus HR. I'm not adding the delta signs. These are the waste of time for the P1, not for the P2. So yeah. So delta H1 minus H2 is equal to delta HR. Now there are 2 moles of ethanol here once again, because we are using the standard, we are using a balanced chemical equation. So H1 is what? A, and you add this by 2 here, 2 into B. So A minus 2B, D is your right answer, because we are using the balanced chemical equations. So if 1 mole of glucose was combusted, then the enthalpy change was A. If 2 moles were combusted, then the enthalpy change would be 2B. So be cautious of this thing. Now again 39. So this MCQ number 39 generally takes most of the students, even those who have got an A star or A in P1 and A star overall. They might they might also not be able to solve this. It is actually very, very simple. So equation for the enthalpy change is shown. The enthalpy change is Q. What is the correct expression to calculate Q? Do not go for Hess's law here. You can try. Like you, I will give you a 1 minute if this was a class, and you should have tried, but you cannot apply any of the Hess's laws here. Uh, you cannot apply any of the Hess's laws components, like of the combustion, of the neutralization, solution, atomization. None of them can be involved and applied here. So the simplest thing you can do here is what? You check for the formation of CO2. Obviously CO2 is being formed, and H2O is also being formed. CO2 is being formed from carbon in the solid state, so this is its formation. And similarly H2O is being formed from hydrogen and oxygen in their normal physical state, so this is also formation. So formation of CO2 and formation of H2O, this makes us confident after applying 2 and 3 here. So 2 formation of CO2 and 3 formation of H2O will give us the enthalpy change. I'm moving on. Question number 40. Reaction pathway diagram for the aqueous sodium hydroxide and dilute sulfuric acid is shown. Okay, what is the value of enthalpy change of neutralization? Again, there is a trick here. Now first of all, you should try yourself, but there is 2 moles of H2O being formed. You have to get 1 mole. So 1 by 2 Na2SO4. Okay, and NaOH plus 1 by 2 H2SO4. So this is how the enthalpy change of neutralization's reaction would be seen, because we have to make 1 mole of water. So if now you can clearly see this is the enthalpy change of neutralization. I do not have to tell this. If this was for 2 moles of NaOH, or you can say for 2 moles of H2O produced, I can simply divide this by 2 to get for 1 mole of water. So C is your right answer. Okay, so we move on to question number 41. Enthalpy change of formation of NO2 is this, of formation of N2O4 is this. What is the standard enthalpy change of reaction 2NO2 to 2N2O4? So 2NO2 N2O4, and they are made from the same atoms. So 2O2 in this way and in this way. Now according to this, the formation of NO2 is 33.2. This 33.2, but there are 2 NO2 being formed. So you multiply 33.2 with 2, because there are 2 formed. So this side is 66.4, and N2O4 is obviously 1 is formed, 66.4 and 9.4. We have to find this in the HR here. Again, I am not explaining the vectors. Vector addition आपने खुद करनी है. You have to do the vector addition on your own. तो वेक्टर कर लो इसके, और वेक्टर से you can derive like you would get so this is the resultant now. So 66.4, 66, No, this is not the resultant. This is the resultant. 9.4 is the resultant, and this is equal to 66.4 plus delta HR. So minus 57.2 is delta HR. So A is your right answer. So yeah. So this is a very tricky question. 42 again. It's a very tricky question. Separate samples of 25 cm cube of 0.1 mole per decimeter cube NaOH are added to three different are added to each of the three different acid solutions as described. The temperature of the each of the solutions was 298 Kelvin before mixing. Okay, so which statement describes the temperature rises that occur on mixing each of these three acids separately with NaOH? Equimolar equimolar concentration of the acids, and obviously it is equal moles of NaOH separately being used in the experiments. So obviously there would be no change in temperature. Oh, sorry, there would be an equal rise in temperature. That's what most of the students would say without concerning the standard balanced equation of the titration reactions here. For HCl and CH3CO acetic acid, the NaOH to HCl and NaOH to acetic acid ratio is 1:1, 1:1. But for H2SO4, it is 1 ratio, sorry, no, 2:1. It is 2:1. NaC, now line NaOH, like I should have drawn it. NaOH plus H2SO4, Na2SO4 plus water. So you have to add 2 here. Otherwise, you would not get your answer. Okay. So 2:1 is the mole ratio here. So this means that 0.00, just a second, let me do the calculation. 25 centimeter cube divided by 1000 into 0.1, 0.0025 moles of NaOH are gonna react with, simply divide this by 2 because there is a 1 by half ratio of moles. 0.00125 moles of H2SO4. Done. Now we have been given 25 into 25 divided by 1000 multiply 0.05. We have been given what? Just a second. So I was saying that 0.025 moles of NaOH will react with 0.0125 moles of H2SO4. So this would be a complete titration reaction. Whereas in HCl and acetic acid, they HCl is in excess and acetic acid is in excess. So for each of these two experiments, this would take a longer time to the end point because there is now an excess factor of HCl and acetic acid involved. H2SO4 would be used up uh, most fastly. So D is your right answer. The greatest temperature rise must be occurring using H2SO4 because it is present in the required amount, and this would immediately react with HCl, producing the greatest temperature rise. Okay, now we are going for, and another reason why D is correct is because HCl and acetic acid, they would react with 0.00125 moles of NaOH. So obviously this would be producing lower amount of energy compared to H2SO4. So the rise and the gradient of increase must be greater for H2SO4 because HCl and acetic acid are limiting here. So D is your right answer. 43. Okay, so calcium carbide CaC2 reacts with water. Enthalpy loan shown in kilojoule per mole. The standard enthalpy in the formation of the compounds involved. So the total energy on this portion is minus 346, and it is minus 407 here. So minus 346 is being converted into minus 407. So the enthalpy change of the reaction, so this minus 407 is of the total energy on this hand side. This is the total energy on the right hand side, whereas this is on the left hand side. So minus 346 is being converted into minus 407. So you are obviously adding 61, but minus in the left hand side of the number line in the negative. So B is your right answer. Hope you have understood. Okay, so now we move on. Again, there is a misarrangement. Sorry if you are facing any issues. 17th. Yep. This is a similar question we did like this earlier. So the standard enthalpy changes of combustion of carbon, hydrogen, methanol are shown. So which expression gives the enthalpy change of formation of methanol in kilojoule per mole? So you're again draw for the going for the combustion here, because carbon is being combusted and hydrogen is being added, and hydrogen is being oxidized. So CO2 and H2O, methanol here CH3OH. This X has to be found, and this is carbon plus hydrogen plus oxygen. Okay, in the molecular states, in the normal physical states. Okay, not in the atomized. What we have to find is formation of methanol. So according to the balanced chemical equation, I must add 2 here. Done. So minus 286 into 2 for this H2O. I'm going for the combustion of minus 286. Yes, after combustion the products have an enthalpy change of minus 286, which is obviously the water here. I'm multiplying this by 2 because there are two waters here. And for CO2, it is minus 394. It's minus 394. And it is minus 726 for this methanol's combustion. You have to find X, do vector addition. So X plus methanol's minus 726 is equal to minus 394 plus minus 286 into 2, and this I take this to this side, plus 726. So C is your right answer. The best possible solution. Equation for a chemical reaction is shown. All of the substances are in their standard states. Which statement describes the enthalpy change of reaction for this reaction? What is enthalpy change of reaction? Is the enthalpy change when one mole of product is formed from its elements or reactants in its normal physical state. Enthalpy change when one mole of product, or not, 1 mole of xenon trioxide. So this is incorrect. 1 mole of reactants, no. When 1 mole of water reacts, no. When 6 moles of HF are formed, obviously it means 1 mole of xenon trioxide is formed. So D is your right answer. Now part 19, two reactions and their enthalpy changes are shown. So 2C plus 2H2 CH2, C2H2 plus H2 C2H4. These data can be used to calculate enthalpy change for the reaction shown. What is the value of X? This can be done. So again, I'm not be going for combustion now, but the Hess's law must be applied here again. So 2C plus 2H2 is C2H4, and this C2H4 must be making C2H2 plus H2. Why? If we go reverse, we are going for decomposition. So the same products, so the reactants and products would be reversed. and this obviously, if it is giving this, then it must be giving this. This was the total trick involved here. You do vector addition, or I'm simply writing the values here. So delta H here is minus 175 point, no, this would be plus 75, because now we are going for decomposition, in the reverse. So the energy released must be given now, plus 175.8, and this is 52.2. If you do the calculation after vector addition, so this is your resultant. So 52.2 plus 175.8, D is your right answer, 228. Done. So we move on to question number 20. A reaction pathway diagram is shown. So the reaction pathway diagrams are generally very easier compared to the calculations. I'm also fed up of the calculations. Okay, a reaction pathway diagram is shown. Which row is correct? The enthalpy change of forward reaction, it is K, but it must be in the direction in which the energy is increasing or decreasing. So be cautious of this. Activation energy of the reverse reaction, and this would go upwards. This in this direction. So O. So B is your right answer. Following data are needed for this question. Okay, so you have given the data. Formation of formation of water. Hydrazine reacts with dinitrogen tetroxide to form nitrogen gas and water vapor. What is the enthalpy change for this reaction? So the video has taken up to 50 minutes, and I was supposed to complete it in 50 minutes, but I guess it is on the 60% completion now. Anyways, so N2H4 plus N2O4 is giving me 3N2 plus 4H2O. Okay, and both of these things are being produced from the same substances, which are nitrogen in the gaseous state plus hydrogen plus oxygen. So now I'm going for the enthalpy changes of reaction by Hess's law. So this is HR, this is H2, and this is H1. So H2 is equal to H1 plus HR. So H2 is what? N2H4. Okay, let me just see this. So there has been small error. So it is, so the vector addition is something like H1. No, it is H1 is equal to H2 plus HR. So for H1 we have got 4 hydrogens being formed. So formation of H2O is minus 241.8. Multiply this by 4, you would get minus 967.2, and then you add minus 50.6 into 2. So you subtract, and you subtract minus 9.2, so you would get your HR. So this is minus 50.6 into 2 minus 9, minus 1077.4. So A is your right answer. So question number 30, this is very tricky question, definitely an A star question, but like most of the students would get boggled down on this one, but it is actually not that much harder. So he has already given us the energy diagram, thanks to him. So sorry, the flow chart. So delta H2 is equal to delta HR plus delta H1. This is HR. What is H1 here? H1 must be, H1 is this, and this is H2. Okay, so we have to find H1 here. So delta H2 minus delta H R is equal to delta H1. So this is 1300. Why is that 1300? Because this is minus 602, because 2 BRF3 is are being formed. Now this might be clear. So because 2 BRF3 are formed, and this is equal to H1, and according to this, in H1 there are 2 BRF3 being converted from liquid to gas, and for each is 44 energy required. So 44 for 2 is 88. So 1300 plus, I call this the bond energies of BRF3. So this is 1212 is equal to BRF3. So in BRF3 there are total of 6 bonds, because BRF3 3 and multiplied by 2, so there are a total of 6. So 1216 divided by 6 is equal to average bond energy. So this is 202 kilojoule per mole. B is your right answer. Okay, so in order to determine the enthalpy of neutralization of a strong acid and a strong alkali, 25 centimeter cube of 0.2 moles per decimeter cube sodium hydroxide is added to 25 centimeter cube of 2 mole per decimeter cube HCl. The increase in temperature is 12 degrees C. In an experiment, the same method is used, but 50 centimeter cube of 2 mole per decimeter cube sodium hydroxide is added to 50 centimeter cube of 2 mole per decimeter cube HCl. What is the increase in temperature in the second experiment? Now, for the first experiment, Q is MC delta T. You add 50 into 4.18 into 12, so you would get 2500 plus something, but I will take 2500. But this is for 0.05 mole of sodium hydroxide. So 0.05 mole of sodium hydroxide. I won't be telling how I get the number of moles. You should know that moles is equal to molarity, or the concentration times volume. So this is for 0.05 moles, and for 1 mole this means it is 50,000 joules. Okay, so in the second experiment he used 25 centimeter cube of 2 mole per decimeter cube. He used 2 mole per decimeter cube is added to 50. Done. Okay, so I understand. So in the second experiment I will take definitely 50,000 here is equal to 100, because 50 and 50 is 100, and volumes are considered equal to mass multiply 4.18 and multiply temperature difference. So 50 divided by this 50,000 divided by 41 for 10.8, so this is something like 12 degrees C. So B is your right answer. Which equation represents the enthalpy change of atomization of iodine? So enthalpy change of atomization of iodine, so definition is, it is the enthalpy change when 1 mole of gaseous atoms is formed from its reactant molecules in their normal physical state. Iodine exists as solid at room temperature, and I had told you 1 mole of gaseous atoms is formed, so C is your right answer. Do revise your definitions if you are doing this topical. Otherwise, this would not yield you a good benefit, definitely. This is for sure. So we move on to 44. MCQ number 44. A student makes 25 centimeter cube of 4 mole per decimeter cube HCl with an equal volume of 4 mole per decimeter cube sodium hydroxide. So this is actually very simple. Q is equal to MC delta T. I'm not reading the whole statement. So 25 centimeter cube, 25, so 50 into C is 4.18. Temperature difference is 15. So you would get B as your right answer. This is a piece of cake. Literally, it's a piece of cake. I will be doing 45 later on 46, which equation represents the reaction of standard enthalpy change at the standard enthalpy change of formation of water. So for enthalpy change of formation of water is 1 mole of products. So you ignore first D. First of all, 1 mole of products is formed from its reactants at standard temperature pressure in their normal physical states. These are atomized. Ignore them. These are again atomized. We are only left with B. These exist in their normal physical states at STP. Okay, so how many questions we are to do is after this one? Okay, not much. 45 MCQ is a bit trickier. So this let me just solve this and then I would continue the recording. So nitrogen monoxide is rapidly, let me just change the color now. It's rapidly oxidized to nitrogen dioxide. Nitrogen dioxide demers to from this. You should read the whole statement. I'm going directly because I have to save the time obviously for you guys. Now first of all, we would calculate the enthalpy change when nitro enthalpy change of this reaction. I will calculate the enthalpy change of this reaction. Now these both are being formed from nitrogen and oxygen. So this would go one in this direction and the other in this. Formation of NO2 is what he has said. He has told us that it is 34, but there are 2 moles of being formed, so I am writing 68 here. Hope you are understanding this over time. Your concepts should be clear before solving the P1, otherwise this would definitely not help you. Okay, so now 182. Why have I written 182 here instead of 91? Because there are 2 moles of NO being formed. So the enthalpy change for this reaction is minus 114 kilojoule per mole. And again, I'm simply copy pasting this because this reactant side is identical to this reactant side. So this is same as this. So 2NO plus O2 is 2NO2 plus N2O4. So I have minus 114 of this, and he has given us 2NO2 when converted into hydrazine is minus 58. Minus 114 minus 58. D is your right answer. This is how you're going to do this. I've done 46. Now we're going to do is 47. Done. Okay, so enthalpy change for neutralization of HNO3 with NaH is minus 57 kilojoule per mole. Okay, so in an experiment 20 cm cube of 4 mole per decimeter cube HNO3. So this means we are using 0.08 moles of HNO3. Done is with reacting with 30 centimeter cube of 2 mole per decimeter cube NaH in an insulated container. The initial temperature is 25. No heat capacity is this. No heat losses. What is the final temperature of the mixture? Okay, so enthalpy change of neutralization. Write the balanced chemical equation. First of all, HNO3 plus NaOH, NaNO3 plus H2O. So if we have 0.08 moles of HNO3, then we have 0.08 mole of H2O. Calculate the enthalpy change for 0.08 moles of this. If minus 57 kilojoule is for 1 mole, then for 0.08 it should be how much? Now minus, just a second, minus 57,000 multiplied 0.08. So this equals, no, there's an issue again here. We have been given 0.06 moles of NaOH. So HNO3 is in excess. So 0.06 moles of HNO3 and obviously 0.06 moles of H2O would be produced. So this means that the enthalpy change after doing the calculation for 0.06 mole of water being produced is 3420. You divide this by 4.18 into what is the volume? 25, sorry, 20 and 30, it is 50. So this would equal 16 point something, and 25 plus 16 is 41. A is your right answer. So we are moving towards the end. Finally, alhamdulillah. 48. 1 mole of hydrogen reacts with oxygen to give water vapor using the bond energy data. What is the value for enthalpy change of this reaction? This is very easy. So oxygen, double bond oxygen plus H into H, this gives us oxygen, hydrogen, hydrogen. Okay, so for double bond oxygen, this is 496 for 1 mole. This 496 for 1 mole. So this is would be, no, I'm weak in maths. 496 divided by 2, 248. So 248 of this, HH is 436, HO is 463 plus 463. Calculate the different, no, 463 plus 463. This is 926 on the product side, 926 on the product side, and 248 plus 436, 684 on the reactant side. From the products, 926 minus 684 is how much? 242. 242 is your right answer, C. And why is this the negative sign involved? I do not have a reason for it, but 242 is the answer. I'm sure, pretty much sure, 100% sure, because uh, yes. No, no, I'm not sure for the reason, but this is the answer. 49. Which statement about enthalpy changes is correct? Enthalpy change of reaction are always negative. You cannot give an hypothesis of this. Not for this. Enthalpy change of combustion are always negative. Formation, again you are unsure, but for enthalpy change of neutralization in A levels P1, in A1 AS you are sure enthalpy changes of neutralization are always negative. What is the definition of standard enthalpy change of neutralization? Neutralization, when an aqueous acid and an aqueous acid react to produce 1 mole of water. इसका रट्टा लगा लें. Rattalize this, I mean memorize this completely, otherwise definitions you must be 100% sure of the definitions of for the enthalpy changes, otherwise you won't be able to solve not only the P1, also the P2. You will face severe difficulties in solving it. Okay, so last page. Which reaction? I'm going for 53. Which reaction has an enthalpy change equal to standard enthalpy change of formation of propane? Enthalpy change of formation of propane. 1 mole of propane is formed from its reactants in their normal physical states. Carbon is always in the gaseous states, solid, and propane is the gas at room temperature. C is your right answer. Why do we go for any like खांसी डालने की क्या जरूरत है? 52. The enthalpy change for a reaction can be calculated from the values of enthalpy change of formation. This. Okay, so this is a tricky MCQ somehow. Which expression can be used to calculate delta HR? मैंने पहले I have already read whole of the statements. I have already solved a paper, so that's why you should be first reading the statement by yourself. Which expression can be used to calculate the delta HR? Okay, so this is a tricky MCQ. We have got methane and oxygen. This is a balanced equation. So this means this would be producing and this would be producing CO2 and H2O upon combustion, definitely. So what we have to do is delta HR. We have to calculate delta HR. So this is H1, this is H2. H2 is equal to H1 plus HR. H2 minus H1 is equal to HR. For H2 there are 2 moles of ethane being combusted, yes, and 2 moles of methane are being combusted, and these are being minused here, subtracted here. So B is your right answer. एक ही बात, मतलब I had only say one thing. First, clear your concepts, take a look at your notes, then come at this P1. Otherwise, you won't be solving this, and you won't be getting getting your concept purified and crystallized after watching my videos. You shall only be wasting your own time. That's one clear cut key takeaway from this video. I'm repeating this for the like 50th time, I guess. Now 51st is the last MCQ, and it is, I guess, most difficult, if I'm not wrong. Nitric acid is made industrially by the oxidation of ammonia. Overall equation for the process is NH3 plus 2O2 HNO3 plus H2O. This is very tricky MCQ. Literally, it is. So this is for stage 1, stage 2, stage 3. Issue here is the balancing of equations. So you must be going with single ammonia. So NH3, this will take some time, plus 1.25O2, 1 NO plus water. Ignore water for, no, why would be I ignoring water? Just 1.5 H2O. And for NO it is NO plus O2 NO2, and this is half O2 here. And for this we have to produce, so you divide this whole equation by 4. So this is divided by 4. It is remain is this remain unchanged? Yes, it is. No, it is also divided by 2, and this is also divided by 4. So 904 divided by 2, 904 divided by 4, sorry. So minus 226 minus 226 minus 114 divided by 2, minus 57 minus 348 divided by 4, minus 87. So you add these for this one combined equation, because we must be going for the equation 1, which is the balanced one. So this whole is equals minus 370. B is your right answer. Some of you might be doing like they take sum of all these and then divide by 4. This would give us C, but the issue here is this means that we are also taking 4HNO3, 4NO, and this whole equation is disrupted. So that's not how you're gonna approach this question. You are gonna solve for each one of the reactants, like NH3. This is 1 here, so I will go for 1. So that is B here. Like this is NH3 plus 1 and 1.25. This is NO, H2O, NO, NO2, 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 like that. This and that, piece of cake. Okay. So this is how you're gonna approach this question. 51st is B, and this is the end. It is the end. So thank you all for watching first video lecture of A levels chemistry. Make sure to like, subscribe, and press the bell icon to Captain AB's YouTube channel. More of the such videos will be uploaded very soon. Thank you. Take care. Allah Hafiz.